Hi, in this video I'm going to go through question 10 on IMAT 2011. So here we've got Dave and Jeff, who are two security guards patrolling an airbase. And Dave passes the front gate every 8 minutes, and Jeff passes the front gate every 15 minutes. And they've just set off at the beginning of their shift on their individual routes, and we want to know how long until they meet at the front gate again. So if I do a bit of a picture, here is our timeline. This is when they start at the beginning of their shift, and this is time. Then Dave passes the front gate every 8 minutes, and Jeff passes the front gate every 15 minutes. So if this is time 0, then at what times does Dave pass the front gate again? Well, so this first time would be just 8, and then the next time will be 8 minutes on from that, so that's 16, then 8 minutes on again, so 24, and so on. And what about for Jeff? So the first time for him would be 15, and then 15 minutes on from that would be 30, and then 45, 60, so on. So we can see Dave's times are all multiples of 8, and that Jeff's times are all multiples of 15. So what does that tell us? Well, if we want one of Dave's times to coincide with one of Jeff's times, then we're going to need a time that is both a multiple of 8 and a multiple of 15. And actually, because we want the length of time until they meet again, so that's the first time that they meet again, we're going to want the first common multiple of 8 and 15, so that's the LCM of 8 and 15. And there's ways of finding the least common multiple by looking at the prime factors, but here 8 and 15 don't actually share any prime factors, which suggests that the least common multiple is just 8 times 15, which we can work out to be 120. Now, there is a way of finding the least common multiple without writing all of the multiples down, and that involves using prime factors. So, for example, if you know how to do this, then you can skip this part. But if I was looking for the LCM of 8 and 14 instead, then I can say that 8 is 2 times 2 times 2, and 14 is 2 times 7. And then I look at the most times the factor occurs in either number. So here for 2, I've got 3 2's here. So for 2, I've got more 2's in the 8 than the 14. So I've got 3 here. And I have 1 7 in the 14. So for the least common multiple, I'm going to want 3 2's and 1 7, which gives 56. But now we see that 8 and 15 do not share any prime factors, because 8's only prime factor is 2, and 15 has 3 and 5. So the least common multiple of 8 and 15 is just going to be 8 times 15, which is 120. Now, if you didn't want to use prime factors and you just wanted to write down some multiples, then, well, would you write down the multiples of 8, or would you write down the multiples of 15? I would suggest that you should write down the multiples of 15, because 15 is the bigger number and there are fewer multiples. So it's not going to take you quite as long. But the multiples of 15 are here, and you can see that none of them are multiples of 8 until we get to 120, which, as we already know, is 8 times 15. But in either case, we know that they will next meet again in 120 minutes. But if you look at our answers, they want in terms of hours and minutes. So how many hours is 120 minutes? Well, we have 60 minutes in an hour, so if we divide 120 by 60, we will get 2. So they meet again in 2 hours exactly, and that's answer C.